Hello students, today we're going to be solving surface area problems involving composite prisms. Now remember, our composite prisms are just three-dimensional shapes that we just have to find the surface areas for each and then add them together at the end. So let's take a look at our problem. Galv constructed a model building and wants to cover the outside with paper. How much paper will he need to cover the entire model? If we look over here at this shape right here, it looks like we have a rectangular prism on the bottom here and a triangular prism for the rooftop here. Over on the left here is actually the net of that shape. So if we were to unfold this shape and lay it out flat, this is its net. So each part of the roof should measure 10 centimeters by 24 centimeters. Now if you look over here at the roof, you see the slant right here that is indicating the length of this edge of the roof. And the reason why it's saying by 24 centimeters is because if you look at this edge right here, it is the same as this edge down here. So we want to make sure that we are using 24 centimeters when we actually go and solve these later. Over here, another note, it says the bottom, front, and back each measure 12 centimeters by 24 centimeters. So again, we have this side right here. We're going to call this a side. And remember, it has a matching side back here that you cannot see. If I were able to rotate this so you would see that it does have 1, 2, 3, 4 sides. And then we also have a top and a bottom. Now remember, the top is this roof though, so it's a little bit different. We're going to get into that later. So we have our 12 by 24 right here. That would be our bottom. Then also 24 by 12. If you see how we have this 12 centimeters right here, that also means that this length is 12 centimeters and this length is also 12 centimeters. Not the 20 that is indicated right here. That 20 right here is indicating the entire height of the figure from the tippity top to the very base bottom here. Okay, this is something else. We'll talk about that later. The sides are composed of a triangle of a height of, well, we're going to talk about it now. 20 take away 12 centimeters. Here's our 20, which is the total height here. And we're taking away 12 because we see right here, this piece of the figure here is 12, which means over here, this piece of the figure is also 12. So this section is 12, which means the remaining section must be 8 centimeters, which means the triangle in the front here has a height of 8 centimeters. Alright, so first we're going to find the surface area of our rectangle. And we do that by finding the area of each face. And a face is just the front of each side, okay? Alright, so our surface area of a rectangular prism, we're going to be using strictly length times width. Now we have to do the front and the back. So we know the front and the back is a 12 by 12, so this section right here, the area will be 12 by 12. The reason I'm multiplying everything by 2, that's because there's 2 of these. There's one here, and there's one way back here. So the area of the front and back combined is 288. Now our sides, again I have 2 of them. I have a side here, then I have a matching side in the back here that you cannot see. And our lengths are 24 and 12. See that here, 12, which matches here. So that means I have to take the 2 sides, and then we'll do our parentheses 24 times 12, and altogether that gives me 576 for just those 2 sides. Now the bottom, I am not multiplying by 2 because look at this, that top does not match that bottom, which means the bottom, there's only one surface area for it. So that's just 12 by 24. We get 288 again. To get the total surface area, we simply add up all the areas of the faces, and I get 1,152 centimeters squared. Remember, area is always squared because it is 2-dimensional. Next, we're going to be looking at the surface area of the triangular prism. Now, the triangular prism is up here. It's just this roof piece here, but the roof piece, looking at its surface area, we've got 2 different shapes. We've got a rectangle here, and we've got a triangular shape here. So we're going to be using the roof sides. We'll use the rectangular area formula, and the front and back of the roof, we will use the triangular area formula, okay? So our 2 sides, that's here, that's our rectangles, that's what I'm using here. We have 10, because remember that slant was 10, by 24. Remember it matches up down here, so this side is 24. Multiply that out is 480. Remember there's 2 of those pieces. The front and back, these are our triangles, and we actually have to do a little bit of PEMDAS here. So we're going to start inside our parentheses. We'll do our 12 times 8, then we will multiply it by a half, and then we will multiply it by 2, and we get 96. And that is just this triangular piece right here, along with its matching counterpart in the back. To get the total surface area of the triangular prism, we will add these two together, and we get 576 centimeters squared. Now we're not quite done yet. We actually found the surface area of the individual shapes here, and then we have to add them together to get our composite surface area. So I simply take the surface area of the rectangular prism and add it with the surface area of the triangular prism. There should be a plus sign, not an equal sign. And you get 1,152 plus 576, which gives me a total surface area of 1,728 centimeters squared. If you have any questions on this, feel free to reach out. Remember to use the areas for the prisms that you are using. If it has a base of a trapezoid, you need to use the area of a trapezoid. If it has a base of a circle, you need to use the area of a circle. Alright, if it's a base of a square, you can still use length times width, or you can use side squared. Many different area formulas. Again, reach out with anything that you guys might need.